So today we are going to be able to utilize a tape diagram to find an equivalent ratio knowing more than or the total in a ratio problem. So looking at example 2. The superintendent of highways is further interested in the number of commercial vehicles that frequently use the county's highways. He obtains information from the Department of Motor Vehicles for the month of September and finds that for every 14 non-commercial vehicles, we're going to go ahead and highlight that, 14 non-commercial vehicles, there were 5 commercial vehicles, so we're going to highlight that. So we have 14 non-commercial vehicles to 5 commercial vehicles. If there were 108 more non-commercial vehicles than commercial vehicles, how many of each type of vehicle frequently uses the county's highways during the month of September? We're going to go and highlight where it says 108 more non-commercial vehicles. And let's also circle the word more. This word more is telling us something really important, and we'll see this in the tape diagram in a moment. So the first thing we're going to go ahead and do is write the ratio. But let's go ahead and put the label like in the form of a ratio so that we can keep everything organized and labeled. So we're comparing non-commercial vehicles to commercial vehicles in that order. Remember, order matters. So non-commercial vehicle. So we're going to go ahead and use the letter N for non-commercial vehicles, and we'll use the letter C for commercial vehicles. We'll put our equal sign. And let's write the ratio that's associated to each of those. The non-commercial vehicles, it said that there were 14. It says it right here, 14. How many commercial vehicles were there? It says that there were 5. And I see that right here in the problem. There are 5. We're going to draw a tape diagram to help us figure out how many of each type of vehicle frequently uses the county's highway. So let's go ahead and put equals, and we're going to make our tape diagram. Now you might recognize that that first tape diagram is going to be pretty long because there's going to be 14 sections to it. So maybe make your sections kind of on the smaller side. So let's go ahead and make that now. In the story problem, it said that there were 108 more non-commercial vehicles than commercial vehicles. Can you please put a rectangle around that? So what we need to do is we need to see what part of the non-commercial is showing more than the commercial. So if I take my highlighter again and I show the 1-to-1 correspondence, these two would be the same, these two are equal. So as we keep going, so far those ratios would be equal, like 5 to 5. But then it's not equal anymore. We then get to a section where it's showing more on the non-commercial. The more is this leftover section right here. So I'm going to draw a little bracket to kind of separate or emphasize the piece that's showing more. How many more sections is that? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 sections there that's showing more. Well, they said that this more is 108. So we're going to write 108 right there. So if that more is representing 108, and there are 9 leftover sections that's showing more, we need to figure out how much each of those pieces is worth. What we need to do here is take the 108 and divide it by those 9 more than sections. So 108 divided by 9. Well, 108 divided by 9 is 12 because 9 times 12 is 108. So that means each section there is valued at 12. So I'm going to put a 12 in each of these. So if in my tape diagram all the sections are equivalent, if each of those are 12, then that means all of them are 12. So then I'm going to extend this and put 12s in all of the other ones. So let's go ahead and do that. So we have 12 in each of these as well. And then we could go back to the story problem and see what it was asking us to do again. In the story problem, it asked, how many of each type of vehicle frequently uses the county's highways during the month of September? So it wants to know each of the vehicles. How many each? So that means we need to figure out how many non-commercial vehicles are there and how many commercial vehicles. So in order to do that, all we need to do then is take that 12 and multiply it by this 14. So that would be 12 times 14. And then take this tape diagram and do 12 times 5. So let's do 12 times 14. So we have 12. So 12 times 14. So 4 times 2 is 8. 4 times 1 is 4. Put a 0 as a placekeeper. 1 times 2 is 2. 1 times 1 is 1. And we're going to add those together. So we're going to get 168. So this equals 168. And then we have 12 times 5. And 12 times 5 is 60. Right? 60. Representing. The 168 is representing the non-commercial vehicles, and the 60 is representing the commercial vehicles. So if I scoot this over a little bit, I can show it over here. So this right here is the 168, and this piece right here is the 60. So to write this in a complete sentence, we can say, using ratio language, for every 168 non-commercial vehicles, there are 60 commercial vehicles. The ratio of the number of people who own a smartphone to the number of people who own a flip phone is 4 to 3. Let's go ahead and highlight that ratio, 4 to 3. This 4 to 3 is representing the people who own a smartphone to who own a flip phone. So I'm going to highlight that. If 500 more people, I'm going to highlight that, 500 more people, and I'm going to circle the word more, that's a key word there for me, own a smartphone than a flip phone, how many people own each type of phone? So we're first going to go ahead and write our ratio. Let's first put the labels. So it's comparing smartphones to flip phones. So I'm going to go ahead and write smart over flip. Smartphones to flip phones. And then we're going to put equals. Let's go ahead and put that ratio. Well, since smartphones is listed first and the number 4 is listed first, that 4 is associated to the smartphones, so that has to be my numerator. And this 3 is listed second, and flip phones was listed second, so then I'm going to put a 3 here as my denominator. Now I'm going to draw my tape diagram of that. So I'm going to draw a diagram of 4. And then I'm going to draw a diagram of 3. When I draw that 3, I need to make sure the first 3 line up with the first 3 on my 4. So I'm going to do the best I can to try to make sure that they line up. So it said that 500 more people own a flip phone than a smartphone. Well, the smartphone diagram is that top one, and then the bottom diagram is for the flip phone. So since it said more, I need to focus on the piece of the diagram that's showing more. So if I go to my smartphone diagram, the piece that's showing more is this section right here that's extending past the second diagram. So go ahead and put a bracket right there, and we're going to write 500. because that more than is that 500. Now, since there's only one part of that diagram that's 500, that means I don't have to do any dividing. It's not like I'm taking it and having two pieces that I need to break up into the 500. So that means if there's only the one piece, then that means each of these has to be 500. So I'm going to write 500 in each of these here. Okay, so now I can go back and answer the question where it says, how many people own each type of phone? So I need to figure out how much for each type of phone. Well, let's do the smartphone first. There are 4 500s, so that's 4 times 500, and 4 times 500 is 2,000 over, and then there are 3 500s, so that's 3 times 500, and that's 1,500. So now we have our answer. We're going to write this using ratio language. So our ratio language is for every 2,000 smartphones, there are 1,500 flip phones or 1,500 flip phones.